Hi everyone, today we're going to talk through how to perform excess and limiting reactant calculations. So in this question, this is split into two parts. The bottom half is covered in a different video where we look at calculations from balanced equations. The first half though is the higher excess calculation. So I've already went ahead and written the equation. It must be balanced. It is normally given for you. So if we then try and pull the numbers from the question before we begin. So we have 7.5 grams of calcium carbonate, which is that one there. And we also have 4 mole per litre, 25 cubic centimetres of hydrochloric acid. So we have now taken all of the numbers from the question and match them to reactants or any substance available. Now what I'm doing is underneath the thing it matches, put in what the value is based on your three triangles. So 7.5 grams is a mass, so M equals 7.5 grams. Hydrochloric acid, we have 25 cubic centimetres, which is a volume. We need it to be in litres, so we will do that just now. 0.025. We also have 4 mole per litre, which is a concentration. So I've now just tidied up and taken everything from the question. So it's asking me to show by calculation which reactant was in excess, so out of these two, because they are reactants. There is a method to this. First of all, we would calculate the number of moles of both reactants. We then perform a THN ratio, which I'll explain once we're there, and then at the end you must write a sentence. So the first part then, number of moles of both reactants, you will need to refer to your triangles and decide which one to use for each question. So for calcium carbonate, step 1, number of moles of CaCO3. I have a mass, so I'll be doing mass divided by gram formula mass, which is 7.5 from the information divided by 100.1 if you calculate that. This works out to be rounded to 0.07 mole. For HCl, I have a concentration and a volume, so C times V, concentration triangle, which is 4 times 0.025 from up here. That equals 0.1 mole. So step 1's done. Then for our THN ratio. So this is where you take the two reactants, so the two things you know about, which is CaCO3 compared to 2HCl. So that's taken straight from the equation up here. Ignore the rest of it just now, it's just reactants. Then the THN part, so T is theory. This is from the equation. So this is like your mole ratio. So calcium carbonate, there's one of it, so it's 1 mole. Whereas 2HCl, so it's 2. H is half. Now this here is taken from up here. This is what you have. So put them underneath the correct side. So I have calcium carbonate 0.07 moles. So I write it underneath calcium carbonate. HCl I have 0.1. The half section does not match the theory section. This is on purpose. Do not compare them. The numbers do not relate at the moment. N section is need. So theory, have, need. For need, I'll write a sentence here to help. If you have your calcium carbonate. So you have 0.07. How many moles of HCl do you need? And this is based on the theory. So at this point, ignore the H line. So you've already taken the number you need for it, 0.07. Ignore the rest of it now. So ignore 0.1. You want to compare to this ratio up here. So if it's 1 to 2, it should be 0.07 to 0.14. So be very careful. A lot of people at this stage get this number by just doubling the number above. So they would say 2 times that and get the answer. That is not what's happening here. Ignore this section, you just double the number here. If it was 1 to 3, you would triple the number here and write it. So at this point, you then take the numbers on the right and you'll see they're different. So you have 0.1, you need 0.14. So you need a wee sentence here to help. You either would write less or more than needed. So in our case, we have less than needed. 0.1 is lower than 0.14. So have less than needed. If you have less, this is your limiting reactant. If you have more, it will be excess. So that is just a little side note to let you decide. So because our sentence is have less than needed, this HCl is our limiting reactant. Have less than needed. So HCl is the limiting reactant. Now, the original question said, show by calculation which reactant was in excess. So if it asked for what one was limiting reactant, this would be enough. That sentence would award you the mark. But it's excess. So if it's excess, it's just the opposite reactant left. So in this case, CaCO3. So you would need a final sentence to actually point out the excess. So I would write CaCO3 is in excess. And that would be you finished. I'll add an extra note here just to point out some extra parts that may be referred to in questions. You may be asked to decide how much is it in excess by, or how much is left of it. So in that case, you decide, well, how much did you use of the limiting reactant? So I will write, due to only using 0.1 mole of HCl, because that's all we had, so that's all we could use. We only used 0.05 moles of CaCO3. Reason being, if we go back to this ratio, we had 0.1 moles of HCl, so that's all we used. So if you are using the 1 to 2 ratio, ignoring all of these numbers, if you only use 0.1 mole of HCl, then you only needed to use 0.05 mole because it's 2 to 1. So you would half that. So only needed that. So there is 0.02 moles left over. So that is your excess. I know it's 0.02 because I had 0.07. I only used 0.05, so that is how much I left over. So that's that question finished. The second half of it is quite unusual to be asked, but could be asked, is to then take it further and decide, well, how much carbon dioxide did you make? So in this case, you need to be aware that the limiting reactant determines the product. Because if you have ran out of something, you can no longer make your product. We've ran out of our HCl. So in this bit, this is a little bit easier. You compare your limiting reactant to the product you want to know about. So 2 HCl from the equation compared to CO2. That is a 2-to-1 ratio. Now this part comes from your have section. So the yellow up here, we had 0.1 mole of HCl. So that gets rewritten down here. It's your have value. So 2-to-1, so that would be 0.05 moles. You want to know the mass of CO2. So mass of CO2 equals N times GFM, which is 0.05 times 44, which is 2.2 grams. And that's finished.